Welcome to solverfy.
So let's first draw a free Barta diagram. That's, oof, my apologies. There we go. And so we have a mass here. Perpendicular to the surface will always be normal force. Going straight down will always be the force of gravity. And then here, this is the direction of the acceleration, and we're going to define our new Cartesian axis. This would be our y-axis, and this would be our x-axis. So essentially here, we can just say y. So essentially here, we're defining a new Cartesian axis in order to make evaluating it easier. We're going to say that the effective acceleration due to gravity would be equal to the acceleration due to gravity g plus the acceleration of the elevator. So for part A, when the question is telling us that the acceleration of the elevator equals 0.5 g, we can say that the effective acceleration due to gravity would be equal to 1.5 g. So we can say that the relative velocity is going to be equal to the effective acceleration due to gravity times sine of theta, where this angle here would be theta. We can say that this is going to be equal to 1.5 times 9.8 times sine of 32 degrees. And so the relative acceleration is going to be equal to 7.79 meters per second squared. So this would be our final answer for part A. For part B, now the acceleration of the elevator is equaling negative 0.5 g. So this means that the effective acceleration due to gravity would be equal to only 0.5 g. And so we can say that the relative acceleration will be equal to the, we can just say 0.5 times 9.8 times, again, sine of 32 degrees. And this is giving us 2.60 meters per second squared. Now, my apologies. Yeah, just wanted to confirm the units. For part C, we know that the acceleration of the elevator equals negative g. So here, the effective acceleration due to gravity is actually 0 meters per second squared, which means that the relative acceleration will, of course, simply be, again, 0 meters per second squared. So at this point, for part D, we know that the acceleration of the elevator here equals 0. So the effective acceleration due to gravity will simply be equal to the acceleration due to gravity. And again, the relative acceleration will be equal to 9.8 sine of 32 degrees. So the relative acceleration will be equal to 5.19 meters per second squared. So this would be our final answer for part D, our final answer for part C, and final answer for part B. That is the end of the solution. Thank you for watching.